Hey buddy, so importance of Saga design pattern in microservices. First of all, there is no abbreviation, there is no full form of Saga. If you go over internet, you will see the reason the full form abbreviation was never disclosed, but it was first introduced in 1987. Yes, 1987. The main idea to introduce Saga to, keep the data consistency between different microservices. Because that, when you work with microservices, it is very possible that every microservice have their own local database, right? Now, when one microservice communicate with other microservices, that we have to keep the consistency between different databases, right? Different local databases. For that reason, Saga design pattern was introduced, right? And you know what? There is other name also. Sometimes people call it LLT, and it has abbreviation. So the abbreviation is long-lived transaction. Now over here, when we are talking about transaction, we are talking about database transactions, right? The whole idea is to maintain the data consistency between different microservices database, right? Now, if you look at this diagram, you will see all these are different microservices, right? You will see order API, right? It has their local database. Then inventory API has their own local database, payment API own local database, delivery API own local database, right? Now, if you try to understand, if the Saga design pattern was implemented, how it will work. So let's say user has requested an order. That means we are talking about one of the shopping website, right? So user has placed some order. First of all, that request will go to order API, right? And order is created successfully, right? And that data will saved into order API local database. Now after that, it will make a call to inventory API. Inventory API, this API will store the data for product, for the inventory, what product was purchased, right? And it will save the information in their inventory API local database. Now after that, when the product was finalized, user has to make a payment, right? Then it will go to payment API, right? And it will save the information into local database. And then finally, the order has to be delivered, and that will make a call to delivery API, right? Now, it's fine that, everything went successful. But, what if, let's say, user was placing an order was done, order is created, while making a payment, there was some issue, there was some error, that what will happen, right? So in that case, this Saga design pattern is very, very useful. Now, if you look at this diagram, you will see, this is, we are saying undo the transaction. So there is a concept called undo the transaction or compensating, right? So finally, what will happen? We will refund the money, and that information will get saved into their local database, right? And then further, product also has to be cancelled. We again need to save that information into their local database, right? And then finally, the order which was placed, that needs to be cancelled. Now that data also needs to be saved into the order API. So actually what happened if any case, right? Because different APIs are working with each other, communicating with each other, and if there is an issue happen while placing a transaction, whether it's inventory API, payment API or delivery API, right? It could be any error, whether technical error or any sort of other error. We have to start the undo transaction, right? And then we have to maintain the data in every place. So that is what the Saga is. So with this, we understand what Saga is, right? And how it actually works, but how to implement, right? So there are two strategies to implement Saga. One is choreography. It's not that dance choreography, right? So it's that Saga choreography. And the other is orchestration. Now these two are different. Now when to use orchestration and when to use choreography, right? Let's take a look at this diagram, which is the first strategy, first way to implement Saga, and that is called choreography, right? Over here, you will see the same example. Order is created, inventory is placed, payment is done, and then finally order is delivered, right? But two things are different here. One you see in the diagram, that is success, and second is fail, right? Now these two things are attached at every step between every two APIs, right? You see between order API and inventory API, both the steps are attached. Same for others also, right? Now let's try to understand the success case. So let's say order was created, and now over here it will check if it was success or not. Let's say we are only talking about success for now. If it is success, then it will make a call to the next API, right? So it will make a call to inventory API. Now let's say inventory API also got successful, right? There was no issue. Then it will make a call to payment API, right? Same in the payment API, everything went well, then again it will check the success, and finally order will get delivered. But what if there is any issue at any step? What if there was a failure while updating the inventory? What if there is a failure while updating the payment? What if there is a failure placing the order, right? So what will happen in that case? So again it's the same, that undo the transaction. Okay, now let's start from the last. While delivering the order, there was some failure. In case of any failure, it will go back to the previous step, the previous API, and the last API will make a call to the previous API, and it will tell that API, hey, there was something went wrong, please update your database and just refund the money. And then that API, in this case it would be process payment, which is payment API. It will make call to the previous, which is inventory API, and then inventory API will make a call to order API, right? So every step will make a call to other every step. Tell the APIs, please update your database, something went wrong, right? So this is the first approach, which is choreography. Now this approach is good for small applications, right, where the things are not much complex, where that only 4 or 5 microservices are going to work for a long time. Because if tomorrow you have to introduce one more API in between, somewhere in two APIs, you would have to worry about those success and failure, right? Because all of these things are very tightly coupled, because depend on the next step and previous step, right? So this approach is good for simple workflow when there is no additional microservices we are going to introduce in between any other microservices, right? Now what if we know that tomorrow, in the future, in next 1 year, we are going to introduce more microservices, right? So what approach we should go for? For that, there is an approach called orchestration, right? So that is not tightly coupled. That is not dependent on predecessor or successor, right? So over here, if you look at this diagram now, you will see there is no tightly coupled. There is no direct communication between any other API, right? So there is something concept called orchestration, which would be the center point, right? It is also called orchestrator. It is also called Saga execution controller, right? So what will happen over here? Every communication will happen through that orchestrator, right? When the order was created, it will make a call to orchestrator, trigger the event to orchestrator. Then orchestrator know what API next I need to make a call, right? It knows, okay, I will make a call to inventory API, right? So if something went wrong at the inventory API, orchestrator know that what event I need to roll back, or which API I need to call if there is any error, and which API I need to call when there is success case. So basically orchestrator have both the information. In case of error, what API I need to call? In case of success, what API I need to call, right? So that is why you see participant 1, participant 2, participant 3, participant 4, all the participant, because these microservices in orchestrator are being termed as participant, right? So all these microservices, all these participants are never going to communicate directly with each other. They have to pass the message to orchestrator. Hey, if there is something success, make a call to this API. If there is a failure, make a call to this API. So orchestrator knows everything. So now, this solve the issue when, tomorrow, like after 1 year or 6 months, you have to introduce one more microservices or two more microservices. Now over there, when new microservices are introduced, you don't need to worry about, here I need to attach this microservice to that microservice. No, you just have to focus on the messaging system, right? Just worry about orchestrator. Just pass the success API and failure API, and orchestrator will take care of all the thing. So that means choreography is good for simple workflow when we know, there is no chance that we will introduce any new microservices, right? But if there is a complex workflow, when you are not sure how many more microservices you need in the future, go for orchestrator strategy, right? Okay, so that's all for today video. I will see you in the next video.